Hey guys, today we're going to take a look at vectors algebraically. You're still going to see some pictures, but then we're going to kind of get rid of these pictures and we're not going to need them. So first thing to understand is a vector with its initial point at the origin, so if a vector starts here, it's called a position vector. And we can write this vector algebraically by knowing how much this vector moves in the x direction and how much it moves in the y direction. So this is going to look like an ordered pair. In fact, if it's a position vector, the terminal point is this ordered pair. So this vector goes over some a amount and it goes up some b amount. But we can write the vector using these like different parentheses. These are called chevrons. Okay, but when you see these pointy parentheses, we're talking about a vector that moves a certain amount in the x direction and a certain amount in the y direction. So this would be vector AB. So like for example, this vector goes 1, 2, 3, 4 in the x direction and 1, 2, 3. So we could call this vector 4, 3. And by using those parentheses, we know that we're talking about a vector instead of like just that ordered pair right there. Okay, so this is how you write a vector. The A stands for the horizontal direction, how the vector is moving horizontally, and the B is the vertical component of the vector. Okay, so these two together tell you kind of how the vector is moving. Now, if you look at the next example, this is a position vector. This is not a position vector because it's not starting at the origin. But we can still use this same way of writing. We just have to know how the vector is moving. Now, if you're given a picture, then wherever that vector is in space, you could just count. Okay, 1, 2, 3, 4, 1. You could just count it. But we're not going to be given a picture. I'm just going to give you the initial point. I'm going to give you the terminal point. So where does the vector start and where does the vector end? And we can write its position vector by simply doing the subtraction right here. So if I want to know how the vector is moving in the x direction, I just need to know the difference between this x value and this x value. And if I want to know how much the vector is changing in the vertical direction, I just need to know the difference between this y value and this y value. Okay, and that little formula will give you the position vector of any vector that I give you. So for example, find the position vector of vector v, which we're going to call directed line segment PQ because I'm giving you point P and point Q as its initial and terminal point. So again, it starts with P and goes to Q. So this is the initial point and this is the terminal point. Make sure when you use the formula, notice that it's the terminal point is what you start with. Okay, I want to know the difference between x2, where this vector ends, and x1, which is where it began. So make sure you do the subtraction in this direction. So if I want to know the position vector of this vector that just starts at -3, 1, again, you're not going to have graphs, and 6, 3, so here's 6, 1, 2, 3. I want to know how can I algebraically refer to that vector. Well, it's going to be this x minus that x, so 6 minus -3, and then it's going to be this y value minus this y value, so 3 minus 1, and then that's it. 6 minus -3 is 9, 3 minus 1 is 2, so this is vector 9, 2. That's the position vector. So this vector is exactly the same as a vector that would start at the origin and would end at the point 9, 2, because that's how this vector is traveling. So if you count, you could actually count over 9 up to, and that would take you from the initial point to the terminal point. Okay, so that's how you find a position vector. Again, make sure you're subtracting in the right direction. You start with the terminal and you subtract the initial, your starting point. Okay. All right, the last thing we're going to talk about today is the magnitude of a vector. So magnitude means, so first off, here's the symbol we use. Kind of looks like an absolute value, except we've got 2 lines here and 2 lines here. So that's how we talk about the magnitude of a vector. And magnitude means the length. So how long is the vector? Well, if we've already broken down the direction of the vector into its horizontal and vertical components, that means we can think of this like a right triangle. And if I know the bottom and I know the side here, I can just use the Pythagorean theorem, and that'll tell me how long the vector is. And that's it. So if I want to know what is the magnitude of the vector that we just found, I would just do the square root of 9 squared plus 2 squared. So that's 81 plus 4, that's 85. And if that was a perfect square, I would go ahead and simplify it. If it was not simplified and had like perfect square factors in there, I would simplify it, but that does not simplify, so I'm just going to leave it. So the magnitude of that is radical 85. If I wanted to know approximately how long that is, I could plug that in my calculator and I could get an approximation, but you don't need to worry about that. You can just leave it as radical 85. So if you go back to the very first example I showed you when I explained this vector 4, 3, so over 4, up 3. Well, 4, 3, plug that into the Pythagorean theorem, and that vector is 5 units long. So that's how long that vector is. So this vector has more magnitude than that vector, because this would be a little bit over 9, and that one's only 5. Okay? And that's how you find the magnitude of a vector.